Assalamualaikum and hi. Okay, so now we continue with the next example on the domain and range. So the next example that I want to discuss here is from the slide, which is the example 3. Okay, for the other example, I just skip, and since I already gave you the answer, so please have a look. And if you don't understand, then please let me know. Okay, and this one I think very important for you, for me to explain about this particular example. Okay, so here we have the square root function, but inside the square root function there is 4 minus x squared minus 2 squared. Okay, so now the thing that we want to take note is the domain. I think there is no problem. You can easily, directly find out there is a restriction, right? Because you can see this one is inside the square root, and supposedly this one should be always greater than 0 and also can be equal to 0. So that is very clear with you, which is this one. But then the range, okay, the range, maybe some of you might trap, and you said that the interval z should be always positive. But remember here, you have, as I mentioned in the video, and you have to watch my previous video so that you will understand, and there is a single constant, so meaning that there is a possibility that the range can be has some interval. Okay, but we have no idea at the moment what is the interval. So the range should be lying between which is which. Okay, so now we want to look on that. Okay, so I'm using this one. Okay, so here the function is the square root of 4 minus x squared minus y squared. Okay, so domain. Okay, about the description of the domain, so please follow the template as given, because I can see from the exercise that you submitted, there are some of you just use whatever you want to write, even though I can understand your domain. You want to tell me that the domain, the value of xy can be any number, but you have to follow the template. Okay, if you want to get a correct, the full mark, make sure you follow the template, you follow the rule in writing the description of the domain and the range. So the domain is the set of the xy where x, y are real number, and then from the function we know that the value of 4 minus x squared minus y squared should be always positive and can be equal to 0 as well. Okay, so now range. Okay, range is the value of z, and z is real number. Okay, so here, because as I mentioned before, we have so the whole expression on the right is square root of 4 minus x squared minus y squared. And here, because we have the standalone constant, okay, so meaning that there is a possibility that value will become the interval of the z or the range. Okay, now in order for us to investigate what is supposedly the interval value of z, so then we use the same technique as I explained last time, from the last video. Okay, here we know that 4 minus x squared minus y squared will give you some values, right? Okay, but then we want to see the what is the possible value in the square root here. Okay, so now we want to investigate further. So we can rewrite this to be in this form. Okay, now we know that this value in the bracket always positive, right? So since this one is always positive, so what is the possible value then? So you can see that, okay, I can put the smallest one is 0, right? 0, 1, 2, 3, 4, 4.5, and so on. So I put 4, I put 5. Alright. So now that is a possible value. So now because of the function, there is a square root. So you put the square root, then you put the square root. So that is the value of z, right? So now you say that, okay, if the value in the bracket is 0, so your z become square root of 4 minus 0. So you got 2. Okay. Can we put negative 1? No, you cannot put, because in the bracket here, you can put any number, even even though the value of x is negative, and it becomes positive because it is squared. Okay, so now we keep increasing the value in the bracket. You can put 0.1. You can put any fraction number as well. Okay, so just to make it easy, so I just put any whole number. So I put 1. So if the value inside the bracket is 1, so the z value become 4 minus 1. So it's square root 3 smaller than 2. And then keep going. We just want to see the pattern. Okay, we just want to see the pattern. I put 4. So z equal to the square root of 4 minus 4, we got 0. Okay, and then what else? Okay, we got 5. And we can add 100 as well. 6, 7, 10, and so on. So I put 5. So now your z value become 4 minus 5. And what is this? Does not exist. How do we know we have something does not exist? So you use a calculator, find out the square root of minus 1. So your calculator will give you math error, meaning does not exist. So if you keep increasing the value in the bracket, let's say 10, okay, 100, and so on. So 4 minus 10, you got minus 6. Square root of minus 6 also does not exist. So you can estimate what happens next. So they are all does not exist. So now back to your result here. So the result that we want to have is only real number. So this is only the possible value of z that we can have. Okay, but if you're asking me, do we need only to put the value 0, 1, 4? No, you can put any number as long as greater than 0. So you can put 0.1, you can put 0.5, and this one we can put 3, 3.1, 2.5, any values. Okay, so whatever values that you put for this particular value here, so the total value, I mean the value of z only lying between, so we can have 0, so the largest one is 2, and the highest one, the largest one is 2, the smallest one is 0. So that is your possible z, only z, the only value of z that we can have. So that is become your constraint of the range. So then by this you can put the constraint. So you can see that the range, which is the value of z, is only lying between 0 and 2. Okay. Okay, so next we want to sketch the domain. So in sketching the domain, you have to refer to your description of the domain. So you can see the constraint there. So the equation for the constraint here will guide you to have the curve on the 2D system, on the XY plane. Okay, so here, this is your equation that you can refer to sketch the domain. So we have, so here 4 minus x squared minus y squared greater than 0. Okay, So here we can have x squared plus y squared smaller than 4. Okay, now in order for you to sketch the graph, you have to just ignore the inequality. Just assume this is equal to 4. Okay, just for the sake of sketching only. So when you have x squared plus y squared equal to 4, we have a circle here. Circle with radius 2. Centered at the origin 2 on y-axis plane. So all the labeling of the axis and also the labeling on the intersection here, they are very important. If you don't provide me the labeling, even though your answer is correct, then you cannot get a full mark. I'm sorry about that. Okay, you have to let me know. Okay, now we have to shade the area. Okay, in order for you to shade the area, you have to refer to your constraint here. So we have a closed loop, closed curve, and we have less than and equal to. When there is a equal to, meaning that you have to provide the solid line, and there is smaller than, meaning that your shaded area is lying inside the circle. So that is your answer. Okay, that is the sketching of the domain. So meaning that what is the information that you can get from this sketching? So back to your description of domain. So you want to say that the possible value of the set of x and y, they must be real number by only lying, again from this constraint, you want to say that the x and the y value can be any number, but with the condition that the point are lying inside the circle. So for any point that you choose, as long as they are inside the circle, this will give you a real number. Okay, this one will give you a value of z. So we can say that the z exists. But if you take any value outside the circle, and I can confirm that your z does not exist. You can check. If you don't trust me, then you can check by your own. Okay,